Welcome to Train Signal. You're watching a lesson on DNS. But what exactly is DNS? Well, first of all, the letters DNS stand for the Domain Name System. But you know what DNS really is? I mean, the way I think of it is DNS is this really awesome thing that allows all of us to be stupid humans. Now, don't take offense to that, because notice I said all of us, and I pointed to myself. What I mean by being stupid humans is that, especially in today's day and age of the internet, it's true even in a corporate network, but if you include the internet especially, we don't want to have to remember IP addresses for all of our favorite sites. Well, it's DNS that allows us to remember a name and then have that name be resolved into an IP address so that the smart computers, right, if we're going to say we're stupid humans, well, they must be smart computers. We allow those smart computers to talk using IP addresses. Now, there's a number of DNS components that you need to be familiar with. There's, first of all, the DNS servers. A DNS server holds a database, which, by the way, is a nice segue into the next component, but I'll come back to that in a minute. They hold a database of names and IP addresses. And that's how a lot of this resolution takes place, is you go ahead and you say, hey, Mr. DNS server, I want to reach this name. And the DNS server says, whoop, okay, that's this IP address. Here you go. Back to the computer so that it can communicate. Now, I mentioned it was kind of a segue into the second component I want to mention, which is the DNS database itself. Well, should be fairly obvious. I pretty much just gave it to you. It's a listing of names and the matching IP addresses. And we say that within that database, it's a list of DNS records. And we're going to talk about some of the specific records later on in this lesson. The last component to really make up the entire DNS infrastructure, if you're going to have servers, well, you have to have DNS clients. And that's all the individual computers that you might be sitting at or I might be sitting at. And we say, oh, I want to get to my favorite website. That client, that DNS client, goes to the DNS server to do the lookup. So that's kind of the real basic what is DNS. So now let's go in and look at some of the individual components and how some of it actually works. So let's talk about something called domain namespace. This is a term that people hear a lot but don't necessarily fully understand what it means. And I will tell you that DNS is one of those things that, and I know I've done this a few different times throughout the course, but you sometimes have to kind of compartmentalize things and learn them piece by piece and let them all come together. So the first thing here is learning this term domain namespace, because DNS is a hierarchical, or I should say it uses a hierarchical namespace. And I have that illustrated here where at the top we start with something called the root domain, which is just a dot. Now, you may find this easier to grasp hold of if you think of the internet while I'm going through this. Okay, if you think of how you look at names on the internet, so when you go to different websites, I will tell you that all of those websites and the internet as a whole, well, its entire functionality is based off of domain namespaces. And even though you might put in something like www.trainsignal.com, believe it or not, there is another dot at the end of com, right? It's technically www.trainsignal.com dot. And that dot at the end is hidden, it's assumed, and it's what's known as the root domain. And the other thing I should point out is that when you look at a name, and I'm referring to, again, like on the internet, when you look at a web browser, we actually read these names from right to left when it comes to the official, how did this domain namespace get put together? So we start with the dot that's hidden, and it's all the way on the right, and that's the root domain. From there, we will have a top-level domain. And in the example of www.trainsignal.com, well, that, of course, would be .com, right? That's the top-level domain. And there's a number of them out there, right? On the screen, I have a few examples, .net, .com, .org. Matter of fact, if you were working in an internal environment, that top-level domain could be anything. It's not that uncommon to see something like .local, which is not valid on the internet, but it is valid when working with domain namespace within a local network if you're not out on the internet. So after we have that top level domain, we move to a second level domain. Now I've verbally been giving you the example of www.trainsignal.com. Here on the screen, I'm going to use a company that's a hypothetical, fictional company that I've used in a lot of my courses. It's named Globalmantics. So it might be globalmantics.com. Okay, and that's now our second level domain. From there, we move into our subdomains. And so again, in an example of www.trainsignal.com, the www is a subdomain. And we'll even learn a little bit later on that technically www usually is not an actual subdomain. It's an alias. Okay, but so let's move away from that train signal example and let's stick with the Globalmantics we have here. We have some subdomains which might be northamerica.globalmantics.com or HQ for headquarters.globalmantics.com or asia.globalmantics.com. And believe it or not, from there we can move down into further subdomains. So I have an example here of sales, which is a subdomain of the HQ domain. And if you were to put that all together, you get sales.hq.globalmantics.com. And finally, if we want to truly, now that's really kind of where we end our domain namespace. Okay, there's no more domains beyond sales. But I do have something else that I want you to be familiar with, and that's something called an FQDN, which stands for Fully Qualified Domain Name. When you look at a computer and you want to know its fully qualified domain name, we still do this process, but there is one more step. And that is if the name of the computer that I have on the screen here is Server A, if that's the name of that computer, then its fully qualified domain name is servera.sales.hq.globalmantics.com. And again, remember, technically, there's another dot at the end of com. We just don't ever actually list it. It's an invisible dot for the root domain. You have to understand this. You have to be able to grasp hold of the idea of these domain namespaces and how they are formatted. Everything in a DNS environment will use this hierarchical naming strategy. Now, once you have grasped hold of this naming strategy and understand what a namespace is or a domain namespace is, from there, we need to understand something called DNS zones. And a zone, or a DNS zone, would be an area of the DNS namespace to which a DNS server can be authoritative. Okay, so a zone on a DNS server is the area of that DNS namespace that we just went through that particular server is authoritative, meaning it has the right to give definitive answers about computers that exist in that namespace. So examples that we have here, if I go back to globalmantics.com and we see we have some subdomains below that of NA for North America or HQ for headquarters in Asia. And then within NA, I might have support as another subdomain there and training as a subdomain there. And although I know on the previous slide I had sales under HQ, we're going to move sales over into Asia. You'll see that I have some highlighted areas. So we might have a DNS server that is authoritative for the support domain. And to be more specific, that DNS server would be authoritative over the support.na.globalmantics.com domain namespace. And the same would be true if we had a DNS server that was specifically authoritative for the training.na.globalmantics.com namespace. Or you'll notice over on the right side of the screen, there is a shaded area which includes Asia and its subdomain sales. That just represents that you can have a DNS server that is authoritative for more than just one specific isolated subdomain. You can have a DNS server that is authoritative for the sales.asia.globalmantics.com domain namespace. But even beyond that, it's authoritative for the entire asia.globalmantics.com namespace. Now, what does this mean, authoritative? What that means is that if somebody in this environment, so we'll say somebody within the Global Mantics enterprise, wanted to look up the IP address of a computer that had a fully qualified name that existed within, let's say, the training.na.globalmantics.com namespace, in order to do that, it would have to go to the DNS server that was authoritative for that namespace. Now, let's talk a little bit about how these DNS servers are able to produce this name resolution, right? I mean, if that's the whole idea, that we have these DNS servers, they have these databases of information that resolves names to IP addresses. You know, you go back to the whole stupid human thing. Well, the way this is done, that database is made up of something called DNS records. Now, there's a lot of different types of DNS records that are out there, and I have just a few of them listed for you here. Okay, so I just want to make sure you understand this is not an all-encompassing list here. Okay, there is many more types of DNS records for all sorts of different types of name resolution, but these are some of the more common ones. So the first one, or really I should say the first two on the list here, we have what's known as an A record, and then we also have an AAAA record, and obviously that's not a whole lot of fun to say, so a lot of people will actually just refer to that as a 4A record. Well, both an A and a 4A record are essentially the same thing. They are both known as host records, and these are the most typical type of record that you will find on a DNS server. These are just the plain and simple, how do we resolve a computer name to an IP address? Those are the most basic records there are. The only difference between an A and a 4A record is that the A record is used with IPv4 and the 4A record is used with IPv6. That's the only difference. Now, the next type of record that I have listed here is a PTR record, or what's sometimes referred to as a pointer record. A pointer record is the opposite of a host record. Instead of resolving a name to IP address, now these are used for resolving an IP address back to a name. Now, I know I've got you scratching your head right now saying, well, wait a minute, why the heck would we ever be resolving the IP address back to a name? Right? We're supposed to be stupid humans. We can only remember names. If I already have the IP address, who cares what the name is? Well, I will tell you that these records are used very often by certain applications. Okay, so it's not so much that the humans will put in an IP address and then you have to convert that IP address back to a name, but certain applications may have that need. And that's what those pointer records are for. Now, the next type of record I have listed here is one that I've already made reference to a little bit earlier on when I had mentioned about the www thing and how that's typically not an actual subdomain. Well, the reason why is because we have certain records called CNAME, which is sometimes referred to by people as common name, or to be more specific, people will call it the canonical name, or very generically, we'll just refer to it as an alias. And the purpose of an alias is to allow users to be even stupider. Is that a word? Stupider? They could be stupider than they already were by only being able to remember names. Now, not only do they have to just remember a name, but it might be a simplified name compared to the actual name of the domain or of the individual server. In other words, if you were to go to www.trainsignal.com, there's a very good chance, and I can tell you it's a really, really good chance, that www is not the name of the actual web server. Meaning the computer that is the web server hosting TrainSignal's website, that server is probably not named www. That's not the actual name of the server. That server might be called something like Web Server 1 or, TrainSignal Web Server or something like that. But rather than users out on the internet having to figure out what the official name of our web server is, we'll just put in an alias. We'll say if anybody puts in www, what they really mean is they mean Web Server 1. This also gives us the ability to have a little bit of redundancy and fault tolerance built in, because maybe it's not a single web server. Maybe there are a list of web servers. Maybe I have web server 1, web server 2, and web server 3, and I can go ahead and say that the www alias points to all 3 of those servers. And then we might even put some weight on it so that we try a certain web server first, and it's not available, we go to the next one, and then the one after that. But that's what a CNAME record is for, is to give you a very simple name or an alias for your users to access you by. And the last record that we're going to go over here, again, there are many more records, but this is the last one that we're going to cover right here and right now, and that is something called an MX record, which stands for Mail Exchanger Record. And this is a record that is specifically used for looking for the presence of an exchange server or a mail server. Okay, I say an exchange server because I'm very used to Microsoft world, and the Microsoft mail servers are known as exchange servers. So an MX record is going to show you where an email server is. So if a user is attempting to send an email to whatever at trainsignal.com, as soon as it gets to that at trainsignal.com, the DNS server that is authoritative for trainsignal.com is going to look for an MX record saying, hey, this is an email transmission, so where is an email server that I'm going to send this to? And again, you can have more than one MX record, and then you can put a weight to it so that you determine the order of the email servers that you want to communicate with. So just to real quickly review, the A or 4A record is the host record, nice simple name to IP address. Whereas the PTR or the pointer record is the reverse, and it's actually what it's known, by the way. I don't think I said that before. It's known as the reverse lookup record. Okay, that pointer record is reverse lookup. It's now IP address to name resolution. We have CNAME or alias to give a simplified name rather than a user having to know the true name of a server. And then we have our MX records, which is specifically for email. You need to be familiar with those records above and beyond all else. There are other records out there, but they get specific to certain needs on a network. Okay, so now that we've learned what DNS is and we've learned some of the issues as far as domain namespace and zones and records and all that fun stuff, I want to talk to you about something called dynamic DNS. And the idea behind this is, well, you know, back in the old days, that those DNS servers and all those DNS records, we had to type them in manually, right? So I'd go over to the DNS server and I'd start making a list of all the different computers on my network. Well, now DNS gives us the ability to perform what's called dynamic updates. And this is where the DNS clients, as they come onto the network, they don't just go to the servers for lookup, but they can also go to the server to give them an update. Basically say, hi, I'm here, and my name is, and my IP address is, so why don't you make a note of it? And as a matter of fact, the dynamic aspect of DNS gets even cooler than that. You may recall learning from another lesson about something called DHCP, the Dynamic Host Configuration Protocol, and this is where IP configuration gets assigned to the clients automatically. Well, we can build in DNS integration to where, when the DHCP server gives out that IP information, the DHCP server can then turn to the DNS server and say, hey, DNS server, I just gave this other guy over here, you know, he's named blah, 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 and I just gave him this IP address, so put that in your database. How cool is that? You don't have to do anything. It all just works. Okay, so that's the really, really, really fun aspect of DNS, making it dynamic. And I will tell you that that does bring us to the end of this lesson. And so with all this knowledge that we now have of DNS, hopefully you can go ahead and, well, like myself, continue being a stupid human where all we can remember is names and let DNS do all the resolution for us. That's all I got for you. I'll see you in the next lesson.